All right, let's look at the homework 6.8, problem number 8. All right, so let's use the L'Hopital's rule to evaluate this limit. All right, so as you can see that as x approaches 0, tangent of 0 is 0. So this guy goes to 0, and x is going to 0. Right, so you have a 0 to the 0th power. Right, so it's one of the indeterminate form. So we're going to use the L'Hopital's rule. Right, so in order to use the L'Hopital's rule, we have to do a little bit of rewriting. X approaches 0 from the positive side, and let's see, we can write it as e to the natural log of tangent of 8x raised to the x, right? So using the property of a log, we can put the x in front of the natural log, but instead of writing multiply by x, I'm going to write it as divide by 1 over x. So this can be rewritten as limit as x approaches 0 from the positive side, and e to the, right, so it's going to be a fraction, natural log of tangent of 8x over 1 over x. All right, so we can squeeze, since exponential function is continuous, we can squeeze this limit inside the exponential function. So we have e to the limit as x approaches 0 from the positive side, and we have natural log of tangent of 8x over 1 over x. Right? So you can see that as x approaches 0, this guy approaches infinity. Right? And as x approaches 0, tangent of 0 is 0. Natural log of 0 approaches negative infinity. So this guy actually approaches negative infinity. Right? So we have infinity over infinity. We can apply L'Hopital's rule. So let's apply that. So we have e to the limit as x approaches 0 from the right. So applying L'Hopital's rule here. Right, so we take the derivative of the top, so that's going to give us, let's see, put tangent of 8x on the bottom. On top, you take the derivative of that, so that would be secant squared of 8x, right, times 8. So maybe put 8 here, right? And then derivative of 1 over x is negative 1 over x squared, right? So let's clean it up a little bit. So we have e to the, right, still have a limit as x approaches 0 from the right, right? So 8 is just a number, and negative sign is just a number, so I'll just put the negative 8 in front. Then we can maybe multiply top and bottom by x squared so that we don't have to have a fraction inside a fraction. So you have, let's say, x squared and the secant squared of 8x. Then you have a tangent of 8x, right? So this way, as x approaches 0, now denominator approaches tangent of 0 is 0. And here 0 times anything 0, so this guy approaches 0. So we have a 0 over 0. So we're going to do another application of L'Hopital's rule. So I'm going to go up here. So another application of L'Hopital's rule. Then we have e to the negative 8. And then you have a limit as x approaches 0 from the right. Alright, so the derivative of tangent 8x would be a secant squared 8x times derivative of 8x would be 8. So we have that. All right, then we have to use a product rule here. So derivative of x squared would be 2x, all right, times secant squared of 8x, all right, plus, all right, then x squared times derivative of secant squared. So it's going to be put 2 in front, and you have a secant of 8x. But you have to multiply by derivative of secant of 8x would be secant of 8x, tangent of 8x. So you have another secant of 8x and a tangent of 8x. And then you have to multiply by derivative of 8x, which is 8. Right? So you can see that we can cancel out. Let's see. So you have a secant squared of 8x here, here, and here. All right? Then I think this is easy enough. As x approaches 0, so you can see that the first term, 2x, so this guy goes to 0. And here, since this guy goes to 0, and times 2, tangent goes to 0, so the second term actually also goes to 0, right? Because tangent of 0 is 0, and you're multiplying by 0 even. All right, so you have 8. So it's a 0 over 8 is going to be 0. So this limit is 0. So we have e to the negative 8 times 0, which is just the e to the 0, which is going to be just 1. All right, so the limit that we are looking for is going to be 1. So let's type it in. All right, so actually we already know. And submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.